Understanding NumPy array indexing for performance. Have you ever wondered how to efficiently access and manipulate data in Python? Today, we are going to talk about NumPy array indexing and how it can boost your performance in data analysis. First off, let's clarify that NumPy arrays are zero-indexed. This means that the first element of an array is accessed with index 0. For instance, if you have a one-dimensional NumPy array, you can use square brackets with an integer to access individual elements. If you have an array called r, you can access the first element simply by using r. Now, what if you want to access elements from the end of the array? You can use negative indices. For example, r-1 will give you the last element. This is a handy trick when you are not sure about the length of your array. When it comes to two-dimensional arrays, which are often used to representing matrices, the indexing becomes a bit more complex. You will use a comma-separated pair of integers inside square brackets. For example, row index, column index, allows you to pinpoint any element in a table-like structure. But indexing is not just about accessing single elements. NumPy also supports slicing, which allows you to extract a range of elements. When you slice an array, you create a view of the original array. This means that any changes you make will affect the original data, which is quite memory efficient. On the other hand, advanced indexing methods let you use arrays of indices or boolean arrays to select multiple elements. This can be less efficient because it returns a copy of the data, but it offers more flexibility in how you manipulate your data. Now, let's talk about performance. Efficient indexing is essential because NumPy arrays are designed for fast numerical operations. By using slicing and vectorized indexing, you can avoid slower explicit Python loops. Accessing contiguous blocks of memory through slices improves cache utilization, which speeds up your computations significantly. Practical applications of NumPy array indexing are vast. You can select rows or columns from datasets, filter data based on specific conditions, and perform batch updates. For example, using Boolean indexing allows you to quickly extract all elements that meet a certain condition without the need for looping through each element. Index arrays can also be used to reorder or select specific elements efficiently. This makes your code clearer and more concise, which is especially beneficial when working on data analysis and scientific computing tasks. In summary, understanding NumPy array indexing involves knowing about zero-based indexing, how to access multidimensional arrays, and the benefits of slicing and advanced indexing. Mastering these concepts will not only make your code cleaner but will also lead to better performance in your data analysis projects.